This was the launch of the Indian rocket called Chandrayaan-3. And this was the launch of the Russian rocket called Luna-25. Both of these rockets went on an important mission, each with the same destination in mind, the South Pole of the Moon. In this cosmic race, the Indian rocket Chandrayaan-3 and the Russian spacecraft Luna-25 embarked on their respective journeys. But in the end, only one of these rocket ships ended up safely at the destination. Spoiler alert, it was India's notorious Chandrayaan-3. To understand what went wrong with Luna-25 and, in contrast, what Chandrayaan-3 did right, we need to delve into the details of these missions and their historical context. Let's take a trip back to the Cold War, when the Russian Lunar program was first introduced and a very similar situation unfolded. Back in 1957, a pivotal moment evolved with the launch of the Russian Sputnik 1, a tiny beeping metal ball that marked the start of the space age. This historic moment ignited a fierce competition between the United States and the Soviet Union, known as the Cold War, which extended beyond political and military realms and reached all the way to the stars. The race to the moon was an essential chapter in this rivalry. Both superpowers were determined to prove their scientific and technological prowess, and the moon became the ultimate symbol of achievement. It was a quest for lunar dominance and to showcase who has got better resources. In 1959, the Soviet Union made the first move by sending the first lunar spacecraft called Luna-1 on a flyby mission to the moon without any crew. Although it didn't land on the lunar surface, it was a significant milestone, demonstrating Soviet capabilities. However, it was the United States that took the next giant leap. In 1961, astronaut Alan Shepard became the first American in space, followed by John Glenn orbiting Earth. These milestones bolstered American confidence and determination. Meanwhile, the Soviets maintained their lead in the moon race. Luna 2 was the first spacecraft to reach the moon's surface in 1959, and Luna 9 achieved the first soft landing in 1966, transmitting images back to Earth. But the turning point came when President John F. Kennedy announced in 1961 that the United States would commit to landing a man on the moon and safely bringing them back before the end of the decade. This declaration galvanized NASA and the entire nation, leading to the Apollo program. The Apollo missions were a series of space flights that aimed to conquer the moon. Apollo 11 in 1969 marked the pinnacle of this endeavor. Astronauts Neil Armstrong and Buzz Aldrin set foot on the lunar surface while Michael Collins orbited above. "That's one small step for man, one giant leap for mankind," Armstrong famously said as he stepped onto the moon's surface, capturing the world's attention and marking a historic moment. The Soviet Union continued its moon efforts but faced a series of setbacks, including the tragic death of cosmonaut Yuri Gagarin. The Lunar program continued with missions to collect lunar soil samples, but the moon race was effectively won by the United States. By 1972, with the Apollo 17 mission, the United States had achieved 6 successful moon landings, surpassing the Soviet Union's lunar accomplishments. The competition had ended and the US emerged victorious. Now, what can we learn from this story? And how does this tie back to Luna-25? Well, the Soviet Union lost most of its missions due to a combination of technical challenges, budget constraints, and the increasing focus on other space endeavors. They were forced to rush their missions to prove their power, and this was no exception for Russia with the launch of Luna-25. Although India and Russia were no enemies, it was still a race for which country would be first to make a soft landing on the moon, and both aspired to claim the honor of being the first to achieve this. But landing on the moon has always been a formidable challenge, with many missions from both the United States and the Soviet Union experiencing failure in the past. Prior to Luna-25, Russia's last attempt at a moon mission was Luna-24 in 1976. So, quite a long time had passed since Russia participated in a new lunar mission. But you might wonder, if they managed to successfully land spacecrafts on the Moon in the past, shouldn't it be easier with all the new technology gained in the meantime? Well, not exactly. An important fact to consider is that both Chandrayaan-3 and Luna-25 made their attempt to be the first country to reach the south pole of the Moon, which is significantly harder than a regular Moon landing due to various factors such as harsher terrain, which is more difficult to navigate, and extreme temperatures variations, with temperatures up to 127 degrees Celsius or 260 degrees Fahrenheit during the day, and temperatures dropping to minus 173 degrees Celsius or minus 280 degrees Fahrenheit during nighttime. Managing these temperature extremes is a significant engineering challenge for lunar missions. But these factors were not very determined for India and Russia's mission to the south pole of the Moon. The most important factors to consider Chandrayaan-3's success and Luna-25's failure are the following factors. Firstly, we have communication difficulties. Because of the Moon's rotation, there are periods when communication with Earth becomes difficult. The lunar south pole is often out of direct line of sight with Earth-based communication stations, which requires the use of relay satellites or complex communication infrastructure. Secondly, there are strict launch constraints. Launching missions to the lunar south pole requires precise timing and trajectory planning due to its specific location on the Moon. This makes mission planning more complex compared to missions to other lunar regions. Lastly, there are limited landing sites. Perhaps the most detrimental factor was finding suitable landing sites near the South Pole that are relatively safe and have access to important resources, such as water ice in permanently shadowed craters. Mission planners must carefully select landing sites to maximize the mission's scientific and operational objectives. So, with these lunar challenges in mind, the big question is, how could India's Chandrayaan-3 successfully land on the south pole of the Moon in contrast to the failed landing of Russia's Luna-25? Well, what if I told you that India's Chandrayaan-3 had an ace up their sleeve that no one expected? This brings us to the history of the Chandrayaan missions, in which India created a secret advantage that was detrimental to their success of Chandrayaan-3. Back in 2019, India made a similar attempt to do a soft landing on the lunar south pole, with Chandrayaan-3's predecessor called Chandrayaan-2. However, unfortunately, communication was lost with this spacecraft, resulting in a failed mission.
Subsequently, the communications from the lander to ground station was lost.
But here's the surprising part. The orbiter, another part of the mission, did really well. It went into orbit around the Moon and is still up there, collecting data about the Moon's surface and trying to detect ice water on the lunar surface. And guess what? It helped Chandrayaan-3 by finding a safe place for it to land, making sure it had a better chance of success. This orbiter component became Chandrayaan-3's unexpected ally. It had spent years meticulously scanning the lunar surface and identifying potential landing sites. When Chandrayaan-3 was in the planning stages, it could tap into this invaluable resource, and it paid off huge in the end. On the other hand, Luna-25 faced the challenge of approaching the lunar south pole without a similar orbiter providing real-time data and reconnaissance. The absence of an active Russian lunar orbiter left Luna-25 with less information to guide its mission, increasing the risks associated with landing. Eventually, this resulted in a failed landing. As Chandrayaan-3 descended towards the Moon's south pole, it had the benefit of precise data, which enabled it to select a landing site that minimized potential hazards. This advantage significantly contributed to Chandrayaan-3's success in achieving a safe lunar landing, a feature that was missing in Russia's attempt with Luna-25. In the end, the story of Chandrayaan-3's triumphant landing on the lunar south pole highlights the importance of careful planning, persistence, and leveraging the knowledge gained from previous missions. Chandrayaan-2 had experienced the same troubles as Luna-25, and Chandrayaan-3 capitalized on this previous knowledge and learned from its previous mission. It demonstrates how space exploration is a continuous journey, where each mission builds upon the achievements and lessons of the past. Chandrayaan-3's success is not only India's, but a testament to international collaboration in the pursuit of lunar exploration, proving that even in the vastness of space, knowledge is the key to reaching new horizons. If you found this video interesting, please consider liking and subscribing to our channel. Until next time.